Here is the interesting question where we'll first find the trigonometric function and then its derivative. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have a very interesting question based on trigonometry. From the given conditions, we'll first find the equation of trigonometric function, then the derivative, and then gradient. So the question here is, graph of trigonometric function f of x has maximum at p 5, 16 and a minimum at q 11 minus 8. Find the equation in the form f of x equals to a sine k x minus d plus c. Find the derivative of this function and find the point on the curve where the gradient of the tangent is. I'm going to change this value to minus 2 pi. So that is the question for you. You can pause the video and answer the question. So looking back, what you need to do here is, first, you are given that there is a trigonometric function whose maximum is at a point P, which is 5, 16, and minimum at a point Q, which is 11 minus 8. So from this, you have to find the equation in the form of f of x equals to a times sine k x minus d plus c. And then you have to find the derivative of this particular function. Once you find the derivative, after that, we want to find the point on this curve where the derivative is equal to minus 2 pi. So there are three parts to this question. I'd like you to pause the video, answer, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given. Most of my students are doing extremely well. They're getting highest marks in the class and scholarships, like Akshit.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Okay, now let's look into the solution. So in part 1, we'll try to find the equation of the trigonometric function whose maximum is given to us along with the minimum. So how do you work this out? Let's make a rough sketch first. So let's say we have a sine function which could be given like this, right? So in the sine wave, let's make it slightly more symmetrical. Okay, we're given the 2 points, the maximum at P and minimum at Q. So this point P is at 5, 16. And the minimum Q is at 11 minus 8. And the function f of x is equal to transform sine wave, which is a sine k x minus d plus c. So one by one, we will find each and every parameter. So let's begin with the axis c, right? So the axis, which is c, is actually maximum plus minimum divided by 2, right? Maximum plus minimum divided by 2. So the maximum value is 16 minimum being minus 8, we'll add them up, divide by 2. So that gives you 8 by 2, which is 4 units. So this line of the axis is at y equals to 4. Perfect. Now, let's find the amplitude. Amplitude is the distance from the axis to the peak. So the amplitude A will be equal to 16 minus 4, which is 12. You could also find it by difference of maximum and minimum divide by 2, right? Or you could also do like this. You could do difference of maximum minimum, which is 16 plus 8 divided by 2, right? So which is 24 by 2 or 12. Same answer. So this height or this is 12, amplitude. Perfect. Now we need to find the time period. So how do you figure that out? Well, time period, half of the time period is between maximum to minimum, right? So this distance is half the time period from maximum to minimum. Perfect. So we can write half the time period t is equal to the difference in their x values, which is 11 minus 5, which is 6. And that gives you that the time period t is 6 times 2, right? Which is 12. So time period is also 12 here. Since the time period is 12, you can find the value of k, right? So that gives you the value of k, which is 2 pi by t, right? So the value of k is 2 pi by 12. That gives you pi by 6. So pi by 6 is the value of k. So the only parameter left is d. Now d is a point on the axis from where the one wave will start. So let's try to analyze how do we figure this out. So in a wave, we know this point here to here is 6. That means the other two halves is 3 on this side and 3 on the other side, right? So this is also 3 units away, and that is also 3 units away. So D is this point we're looking at. So this point D, let me write down here, will be what? 3 left of 5, which is 2, right? And the y value being at 4, correct? So we get the value of D, which is equal to 2, correct? As you can see from here. So this quarter. One wave is divided into 4 equal quarters, correct? Where the midpoint being there, right? So 3 units, each is 3 units away, each quarter. So that gives you the starting point. And therefore, what we get here is the function f of x. I'll write this down as amplitude of 12 sine the k value being 2 pi by 6, right? And x minus d of 2 plus c, which is 4. So that becomes the equation of the trigonometric function. Is that clear to you? Correct? Perfect. Let's move on and now find the derivative of this function. Okay, so what we have done here is we have sketched the sine wave here. As you saw, these are the 2 points given. So these points are at 5 and 16, and this one at 11 and minus 8. At 4, we have this axis, correct? And that is the point which is at 2, correct? So we have this equation which is f of x equals to 12 sine pi by 6 x minus 2 plus 4. Now let's find the derivative for this function, right? So we have the equation. Part B was to find derivative. So let's do part B. So derivative for this function will be equal to 12. Derivative of sine is cosine. So we get cos of pi by 6 times x minus 2. Now derivative of 4 is 0, of course, but we need to multiply this by the derivative of inside function, which is pi by 6 times x minus 2, correct? Derivative of 4 is 0, so let me write 0 here. Okay. So that gives you the value as 12. Derivative of pi by 6 times x will be pi by 6, right? So times pi by 6. Cos of pi by 6 times x minus 2. Perfect. So we can simplify this. That becomes 2 pi cos of pi by 6 x minus 2. Is that clear to you? So 2 pi cos of pi by 6 x minus 2 becomes the derivative of this particular function. Clear? Now let's look into part C. So part C is find x coordinate of the point on the curve f of x where the gradient of tangent is minus 2 pi. So we found the expression for the gradient already. So this was what? We just found it as 2 pi cos of, let me rewrite, 2 pi cos of the same argument which we have here. Okay, so pi by 6 x minus 2, right? So that is the derivative, correct? Pi by 6 x minus 2, 2 pi cos, right? Now this we want to equate to minus 2 pi, correct? Find the x coordinate of the point on the curve where the gradient of the tangent is minus 2 pi. Correct? So we'll equate. So let's solve this now. So when divided by 2 pi, we get cos of pi by 6 times x minus 2 is equal to minus 2 pi divided by 2 pi, which is minus 1. Now when is cos minus 1? Well, cosine function, as you know, is kind of like this, right? And it is minus 1 at pi. So we know the minus 1 will be for cos of pi, correct? And therefore, pi by 6 times x minus 2 should be equal to pi, correct? So we can simplify this. Pi and pi cancel. We get x minus 2 equals to 6 pi, rather 6, right? You can multiply first. Pi times 6 by pi. You write like this, which is 6, correct? So now from here, we can say x is equal to 6 plus 2, which is 8. So at x equals to a, the gradient will be minus 2 pi. Does make sense to you? Perfect. So that is how we are going to solve this particular question. So if you look at the diagram which we had here, so at 8, so this is the point which we just found. At this particular point, the gradient is going to be minus 2 pi. Clear? So I hope the steps are absolutely clear to you. Feel free to share your comments and suggestions. In case you want to learn from me, you can always send an email on this particular address. Thanks for your time and all the best.